Right, guys and gals, let's look at arithmetic sequences. So all that means is you got a sequence, and if you subtract any two consecutive terms, it's going to be the same number. So you skip counting by 2s or 3s or 5s or whatever. So like 2, 4, 6, 8, 3, 6, 9, 12, 5, 10, 15, 20. Anything where the difference between the two numbers is the same. So even something like 2, 5, 8, 11. So 5 minus 2 is 3, 8 minus 5 is 3, 11 minus 8 is 3. The common difference then would be the 3. That's just whatever the difference, that subtraction is, between the two consecutive terms. Consecutive means right next to each other, one after the other. So arithmetic sequence means you're going up by the same number each time. You subtract them, any two consecutive terms, you're going to get the same answer. All right. So in this case, D would be 3. We use the letter D to represent our common difference. All right, determine whether or not these are arithmetic. If so, identify the common difference and give the next 3 terms. So let's see, if I do 8 minus 5, that's 3. 11 minus 8 is 3, 3, 3. So yeah, D is 3. This is a yes. D is 3, give the next 3 terms. So I'm just going up by 3s. 20, 23, 26. Let's see. 16 minus 23. Let's use our calculators because I don't feel like thinking. Is negative 7. 9 minus 16 is negative 7. 2 minus 9 is negative 7. So the common difference is negative 7. Yes, it's possible to be a negative. So to get the next one, we're going to do negative 5 minus 7. Negative 12. Negative 12 minus 7, negative 19. Negative 5 minus 7 minus 7 and minus 7, negative 26. So that'd be the next 3 terms we got. Okay, so 1 and 2 are yeses. Let's check out number 3. 2 minus 1 is 1, 3 minus 2 is 1, 5 minus 3 is 2. So that's a no. There is no common difference here because, yes, it works here and here, but after that, the difference is 2, the difference is 3. Not arithmetic. Okay. So, yeah. We're going to do negative 8 minus negative 6. You can probably look at it and see there is going the same amount. But let's just check out what D is. So we take negative 8 minus negative 6. That's a lot of negatives to think about in your head. So just type in the calculator so you can see, okay, it is a negative 2. And you can see, yeah, we're going down by 2 because the negatives are getting more negative. So D is negative 2. And that's going to be a yes. So negative 16 would be next, followed by negative 18 and negative 20. Let's see what's next. Arithmetic series, no, another one. Going down by 5, going down by 5. Yep, so we're going down by 5. So D should be negative. Oh, wait, 20 minus, that's not going down by 5, is it? But these are, but that one's not. But if they're not all going down by the same amount, then no, it's not arithmetic. Every single consecutive term must have the same difference. So yeah, it looks like it's 5, but it's no, it's not. Not. This one went from negative 20 to negative 10, so it went by 10. Not arithmetic. All right. negative 23 minus negative 35 is a positive 12. If I do negative 23 plus 12, does that give me negative 11? Yep. Plus 12, I should get 1, 13. So D is, in fact, 12 in this case. So this one is arithmetic. And the next three will be 25, 37, and 49. Easy stuff, right? It's just a special name. Now, we can actually figure out any term in the sequence if it's arithmetic. Basically, if it's arithmetic, we got ourselves a linear equation, right? You have a constant slope and a starting point. So a sub n, y, is, your slope, the common difference, x, plus your starting point. This is basically a linear equation, guys. That's all we got going on here. So a sub n equals d times n minus 1 plus a1. Well, why do we have to subtract 1 from n? Well, because we're adding a1 to start with, right? So if we just started at n, then we'd have, let's say, a common difference of 2. So you're saying 2 plus whatever you started is where you're starting? No, that's why you got to subtract 1 from that. All right, so that's the formula. Yeah, you're going to want to memorize it. I have occasionally seen arithmetic and geometric sequences and series on the ACT. So if you're taking that thing again, not something bad to know. Of course, a sub 1 is your first term, a sub n is your nth term, and d is your common difference. This is the only new variable here. Everything else should be familiar to you from last week. So first thing, to be able to do this, we're going to want to find out what our rule is. Let's figure out what's this. So down by 4, up by 4, up by 4, up by 4. So I know that D is, according to this formula, A should equal 10 that to minus 5. So if I plug in 1, that would just be negative 5. If I plug in 2, that would be 4 minus 5 is negative 1. So yes, this works. Let me see. I don't know if they want us to write a recursive formula or an explicit formula or just this. Let's see what the book was wanting here. Yeah, that's all it wanted. So that's their rule that we're looking at. Yeah, that's our A1. That's our common difference. Plug it in. Keep going. And then find the indicated term, 24. Oh, no, we have to list out all 24. No, we don't. We now have a rule, a formula. So we know A sub n, A sub 24 in this case, is equal to 4 times, well, it's A sub n. N is 24. So 24 minus 1 minus 5. 67. 4 times 24 minus 1 minus 5. 87. See, that's why I use a calculator. Don't rely on your head. So 87. That's all they wanted. So the eighth, I guess, 24th. Yes, sorry. The 24th term is 87. Cool. Let's check this one out. So obviously A1 is 20. That's where we're starting with the first term of the sequence. So that's A1. B, I went down by 9, I went down by 9, I went down by 9. Yeah, I went down by 9 every time. So down by 9. Okay, so I should just be able to plug and chug. Negative 9 minus 1 plus 20. It's a positive 20, so I'm going to stick that in there. And I can check. If I plug in 1, that's 0 plus 20 is 20. And then negative 9 plus 20 is 11. It works. Okay. And let's say 15. So plug it in. Yeah, use this. Negative 106. Okay. Or if you listed all the terms and you got to number 15, that number 15 term will be negative 106. But if we think about what's going on here, well, this is actually a rule, right? It's an explicit formula if you think back a couple weeks. But this is still just sequences. Aren't we talking about series? Okay, it's a few slides away. But yeah, we're gonna get there. But now I guess we'll just do this. Down by 3, down by 3, down by 3. D is negative 3. That's where I start. My explicit formula will be this. Plug in 38. Type it in the calculator. And we get negative 117. Okay, moving on. Oh no, so it should be a common difference. So 9.5 minus 8 is 1.5, 11 minus 9.5, 1.5. Use a calculator if you don't see it. Is 1.5, starting at 8. So our explicit formula would then be, 1.5 times n minus 1 plus 8, plug in 48 here. See what happens. 1.5 times 48 minus 1 plus 8. Yes, I'll use the decimal on it. It's fine. This we can leave as a fraction. 157 over 2 is the same 78.5. For some reason, put it as a decimal. Maybe you have a not good calculator. 157 over 2. Okay. Moving on. Okay, this looks different. Let's see. If the given terms are part of an arithmetic sequence, I rule for the sequence and then find a. Okay. So this says basically pretend that we know it's an arithmetic sequence. We got to figure out what the rule is. So we got to figure out our common difference. Okay. I start at 3. Well, so I have 3 something negative 7 is what that's saying. So if I fill in the blank here, We got to add or subtract the same thing every time, right? So I got to go down a total of 10, right? So I'm going down 5 each time. Let's see, -7 minus 3 is -10. So I should be going down 5 each time because I got 2 blanks to fill in. Divided by 2 should be -5. Okay. So 3 minus 5 is -2. Yeah. And then -7. So the way I think about it is how far do I have to jump from here all the way to over here? I had to jump -10. How many spaces did I go? I started here, so don't count that one. Don't divide by 3, divide by 1, 2. That'll help a lot over here. Pretty sure it's going to be going up by 1, but we'll see in a second. Sorry, for me to flip. So a sub n equals, what did I say my common difference? -5. So d is -5, starting at 3. And it wants a 12. Oh, you got -52. Let's just use the calculator. -52. Okay, I didn't screw it. That time. That's a 12. So if we think about what's going on here, I'm starting at -17, and 24 spaces later, I'm at 6. Shoot, that's a lot of spaces. Well, how many spaces is it? It's 23 spaces, right? Blah, blah, blah. We got 23 blanks to fill. Okay, so let's see. 6 minus a -17. That's how much we got to move, right? To find how far we moved, we take where we ended up minus where we started. Minus where we started, so it's minus -17. So we moved 23 units. And guess what? We have 23 squares, right? 24 minus 1 is 23. So yeah, divide that by 23, and what do you think we get? 1. So D is 1. And A sub 1 is that. So A sub n is 1 times n minus 1 minus 17. A sub 12 would just be 11 minus 17, which is -6. -6. Wonderful. That did take a little bit of thinking there. If you have to do this, just see. I ended up here, started here, subtract that, see how much you actually moved, and divide it by the number of spaces, which you just subtract. 24 minus 1, there's 22 spaces between 24 from 2 to 24. Finally, series, what we're supposed to be talking about anyway. Remember, it's the sum of a sequence. To find the sum of an arithmetic sequence, we got a formula instead of talking about this stuff. We already know the formula. Here it is. This is the partial sum of n times a1, starting point, plus an, wherever you're looking at, divided by 2. N's and O's terms, of course. How many terms are we talking about? A1's first term, An's last term. So let's apply this formula. I'm going to take a screenshot of it so I don't forget it. Look, about that goes. So there we go. This is what we're going to use. S sub n, the partial sum, is equal to n times a1 plus an over 2. Okay. So first thing we got to do is figure out a1, an, and n. Well, n is given to us as 10. Okay, so we still need to find out a10. So if you notice, S is the sum, the series, A is the term. I'm going up by 2 each time, right? So my D is 2. I started at 2. So AN is equal to 2 times N minus 1 plus 2. Which term is my last term? A10. So first I've got to figure out what A10 is. 2 times 10 minus 1 plus 2, which is just 20. Type in the calculator. So A10 is 20. That's not my answer though. I now have A1, AN, and N. So S10, the series, the summation, the partial sum is what it really is, of this thing from 1 to 20, or from 1 to 10 will be 210. And that's 2 plus 20 over 2. 22 over 2 is 11 times 10 is 110. Can you figure out why that's working? So we have a common difference, right? And we're going to go that same amount. That's simply the common difference. Well, go ask Euler. He's the one that figured it out when he was in elementary school. But yeah, so this is the formula. It works. If you manipulate this thing, you can probably figure it out. I was going to go off on some tangent, but it's not. And I forgot what I was going to say anyway. Anyway, moving on. The parentheses are negative. So from -6 to -19 to -32, let's see what we're moving. So that's -13. So -19 minus 13 should give me the -32. Yeah. So D is -13. That's A1. We need to find AN. So we need to find A8. 1, 2, 3, 4. So you could actually just write out the next few terms if you rather. Or just write out the formula. AN is equal to -13 times n minus 1 minus 6. So A8 is -13 times 7 minus 6. Type in the calculator. So -97. Not done. It asks for the sum. So S8 is equal to 8 times -6 plus -97 over 2. And that'll give us some number. And yeah, parentheses would be great if you plug in a number, but I got lazy. So -412. Why not? So yeah, the reason this is working, this is averaging them right. So you're finding the average and multiplying by how many numbers you had. And that's how you come up with the sum. Euler, really smart guy. He figured that out in elementary school. There's a whole story about his teacher giving everybody busy work, adding up the numbers 1 to 100, and he did it like instantly with this formula. And the teacher was like, what? But who knows if that's true or not. Go look it up. He's a cool guy. Math person is crazy, you know. All right. So we got some more series. But you're saying it's look just like what we did before. You're right. It's just what we did before. 6x, that means we have a common difference of 6. Right? If we list out the terms, they're just going to be increasing by 6. Let's find out. Let's just do a couple terms. So 6 minus 4 is 2. And then 12 minus 4, that's 8. See, we're going up by 6's, right? That's your coefficient x. Remember, I told you it was a linear equation. Your slope is your common difference. D is 6. So why am I saying D is 6 here? Well, because do you really want to write out 12 of these things when you don't have to? I don't want to write out 12 of them. So what I'm going to do is I'm going to use my formula to figure out what A12 is. A sub n is 6 times n minus 1 plus starting point of 2. I plugged in 1 into here. So I didn't need to find out A1. I found out A1 is 2. So plus 2. And then we're going to do A12 because it says all the way to 12. That's 68. It's 11 times 6 is 66 plus 2 is 68. So yeah, you can check me in the calculator. I know that's right. So now that formula that we have right here, memorized already, right? Yeah, right. So S sub 12, which is what we're doing, right? We're adding up the first 12 terms. That's what this says to do. Is n, which is 12, times, well, the first term is 2 because I plugged in 1 and that's what I got, plus, and I lost my thought, what am I doing? Oh, 68 over 2, 34, 35, whatever, just use the calculator. 420, right? So 68 over 2, 420. This is 12. I just saw that that's 70 over 2 is 35. 35 times 10 is 350 plus 2 times 35 is 70, 420. This partial product, you know, if you want to do math in your head. But don't, just use your calculator. All right, let's look at this one. We don't want to start at 1. We want to start at 8. Okay, we're going to go from 8 to 17. What's the first term if we start at 8? Let's see. So -2 times 8 plus 3. So the first term, if I start at 8, is -13. Okay. I need to find my last term. But if 8 is my first term, what would this be? Okay. So a sub n is this, yada, 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 right? I guess we could just still. So let's write this down. This is A8. A8 is -13. Okay, let's find out what A1 is, because that's this formula uses somewhere here. A1, -2 plus 3 is 1. Okay, so I'm going to do some work over here to find out what A17 is, because my common difference is a -2, because that's what the coefficient of my variable is. That's going to be negative, wait, what? This formula, I just lost. -2 times n is 17 minus 1 plus A1. -2, 17 minus 1 plus 1, -31. Okay, so I know that A17 is -31. I know that A8 is -13. I could list them all out, going down by 2 each time, or I can use this formula right here. So we got to think. How many numbers are between 8 and 17? 9. Okay, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 9. Easy way to do it, you just subtract them. 17 minus 8. Plus 1. Because we have to count the first. I'm thinking here for a second. Hang on. So let's see. N was 12. Yeah, so. Yeah. I think what we need to do is count the A8, right? So A8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There's actually 10 numbers. So yeah, if we need to find out how many numbers there are, we do 17 minus 8 plus the 1 we started with, 10. So this should work if, so S17 here, I guess, whatever you want to call it, the sum, let's just go with the sum. I don't even know what number to put here right now because I'm mixing all kinds of things up, is equal to 10 times my starting plus my ending over 2. So 10 times, I'm definitely going to check the book. I think there's a different way they might want us to do this. Let's see. Should work this way though. We get -220. All right, let's go straight over here. Let's see what they say for number 16. -220. Okay, so they just said it was S10. Okay, no explanation at all there. So I remember vaguely in my high school class us changing these numbers, made this a 1 and then that, whatever that, made that a 9 or whatever, 10. whatever made it. Yeah, we subtract. We need to go 7 down from here, so we go 7 down from here. So 17 minus 7 is 10. So that's where the 10 comes from. Okay. So I remember doing that in high school. But I mean, if you just think about it a little bit, it's how many numbers, including the end numbers, are between 8 and 17. 9 plus 1 is 10. Okay. I think that's enough for today. I think we're good here. That's arithmetic. They got their own special formulas. You know what? I think I'm just going to give them to you on the test because I'm not going to remember them. I don't. Why would I expect you to memorize something that you? Why should I expect you to remember something I don't remember? Right? Right. Go with that. So I'm going to give you these formulas for a sub n and s sub n on your test. I'll probably just project on the board and you can use it. All right. See ya. Sorry about the twisty tongues and confusions and tangents. Probably not watching the video anymore, so who cares? But bye.